This is week 12, introductory activity, log and natural log. Question 1, approximate e to the negative 4 to 4 decimal places. Approximate e to the 0.89 to 4 decimal places. We can use our calculator for that. I hit clear, and there's our e, and I want to raise that to a power. And then I hit set to the 4th power, and I change the sign on that to make it a negative 4, and I hit equals, and there's my answer there, and round it to 4 decimal places. Then I do another one, e to the 0.89, so I hit clear, and I hit e, and I raise that to the 0.89, hit equals, and I have this let's try that one again. I put an extra negative in it. Let's see here, e raised to the 0.89, no negative, 0.89, end up with 2.4351, and that's what I have there. So that's how you get that one done. So this next one here, they have, you end up finding 3 to the negative 1, 3 to the f of 1, 3 to the negative 1, 3 raised to the negative 1. Okay, and let's see here. And you see 0.333, and that's the same thing as 1/3. And I don't see a function in here to convert it to a fraction. Nope. Next one here, I have 3 to the minus 2, so hit clear. Three to the minus 2 is the same thing as 1/3 squared, which is 1/9. And this is 3 to the minus 1, which is the same thing as 1/3, which is 1/3. Without a calculator, you could do that. Okay, so you could do that number 2 without a calculator. And number 3, e to the 7th times e to the 5th, and it's equal to e to the p. So here I have it written out, e to the 7th times e to the 5th is equal to e to the p. That means that p is equal to 12. Next one here, I have e to the 7th raised to e to the 5th. Same thing as same thing as r, e to the r, which is e to the 35th. So r is equal to 35, and that's question 3. Number 4. In this case, determine whether the following equation represents growth or decay. This r value here, the rate, is positive, so it's increasing. R is greater than 0, so it's showing growth. It's showing exponential growth at the same rate, r. And number 5. Convert the equation. F of t is equal to 206 times e times 0.61 to the t to that form there, and round k to 4 decimal places. So first thing I did was I wrote out f of t is equal to 206 times 0.6 raised to the t power. And on top of that, I wrote out to the form f of t is equal to a times e to the kt. Then I identified my a and I identified my e to the k. Okay, so I can see that my a is 206, so that takes that form there. And then I have to find what that k is equal to. So I have e to the k here is equal to 0.6. And here I take the log of both sides, natural log of both sides of it. So it undoes it. They're inverses of each other, so they'll undo it. And it tells me that k is equal to the natural log of 0.61, which is a negative 0.4943. So I know what k is and I know what a is. And then I can plug into my formula here. And that's my answer. Go over it again. Okay. First thing I did was I wrote out my formula here. And I wrote f of t is equal to a times e to the kt on top of it. So I can identify what my a is and what my k is going to be. In this case here, e to the k. So my e to the k is equal to 0.61 and a is 206. I have to solve for k. So the exponential and the log are inverse operations, so I take the natural log of both sides and it gives me what k is. Like a square root undoes a square. So k is equal to a natural log of 0.61. And it gives you a negative 0.4943. And I plug into the formula there, and there's my equation. And that takes care of 0.5 of number 5. Let's go on to number 6. Let P of t equal to 22,000 times 1.04 t be the population of a town 2 years after the year 2000. Estimate when t will reach 27,838. Okay. So I have my equation. So when this population will be 27,838. Okay, so when the population will reach 27,838. So, and there's my population formula there, and I set it equal to 27,838. Okay. And what I end up having to do is divide both sides by 22. Solving for t is what I'm doing. So I end up dividing both sides by 22,000. And then that gives me t by itself. Well, I have to solve for t here. When I divide that out, I end up with something like 1.04 t is equal to 1.26445. So when I get to that point here, so I'll start out with this one, and divide both. I'm solving for t, and I divide both sides by 22,000. And then I have the solving for t. I have an exponential here. So I take the natural log of both sides. Natural log on both sides. Natural log on both sides. Okay. And then I can apply power rule when I bring the t down. So I have t times the natural log of both sides. And here, from here, I can go ahead and simplify it to get 6. So it'll be 6 years later. In this case here, 2006. 2000 plus 6 gives me that value. And the next one, number 7. Population is growing. According to the equation, P of t is 1150 e raised to the 0.18 t. Estimate when t, solve for time, will exceed 3095. So I set that equal and I solve for t. Alright. So I divide both sides by 1150 and I get that value. Then I take the natural log of both sides here. Take the natural log here. Okay. And that gives me the natural logs, they'll be inverses of each other. Ln of e to the 0.18, and that becomes t times 0.18. And I still have the log here, but I can solve for t by dividing both sides. By dividing both sides here, and it gives you my t, which is 5.50014. And that takes care of that one. The next one here, a car was valued at $25,000. In the year 1993, it depreciated to $12,000 in 2005. Used the compound interest formula to answer the following questions. A, what is the rate of change between 93 and 2005? Okay. Okay. For this one here, the car was valued at $25,000 in the year 1993, depreciated to $12,000 for the year 2005. Use the compound interest formula to answer the following questions. What is the annual rate of change between 93 and 2005? So here I have the difference in years. 2005 and 1993 is 12. Okay. And it started out here. 25,000 depreciated to 12,000. All right. And they want us to find the rate. So I have to solve for R. Okay. So I divided both sides by 25,000. Okay. And what I ended up doing here is taking the raising both sides to the 1/12 power. So I took this 12 over 25 and raised it to the 1/12 power. And I did the same thing here, and I got rid of the exponent to the 1/12 power. And I have 1 plus R here. Okay, then I can subtract 1 from both sides, and I have the value for R. And there's my value for R there. Negative 0.0535931, and there it is for your R. All right, and then they wanted that as a percent. It would be a negative 5.93 as a percent. And assume the car value continues to drop by the same percentage. So instead of continues to drop by the same percentage, what would the value be in the year 2010? So We have 2010, the difference is what, 17 years? Okay, and you want to find the value here, that future value there, given the initial value is 25,000. So I have 1 minus 0.0593, and that came from here, the rate of change, decreasing rate of change. Excuse me, 0.9407 raised to the 17th power times 25,000 gives me 8,843, approximately 8,850 for my final answer. And that takes care of number 8. Number 9. Okay. Initially 128 bacteria in the culture. If bacteria double every 30 minutes, choose a model represented. Find the culture in 10 hours. Okay. And the formula that represents it is here. Y is equal to 128 times 2 to the t power. And then it says find in t hours there are 2 doubling periods. There are 2 t double periods. In t hours there are 2 t doubling periods. Okay, so in 10 hours there, put a 10 in for that formula, and the population will be 128 times 2 to the 20th power. You end up with 134,217,728 for your answer, and that's for number 9. Number 10, evaluate the following expressions. We have log of 999 here. So the log asks the question, what is the exponent? So what is the exponent that will give me 9 to the 9? What is the exponent that's going to give me 8? For log, we have 2 here, 2 to the 3rd. You can rewrite that as log base 2 of 2 to the 3rd. What is the exponent? 3. Next one here you have 4, 64. What is the exponent that will give me 4 to the 3rd? 3. The next one you have 3 here. What is the exponent that will give me 3 to the 4th? 4. So logs ask what is the exponent for that base that will give me that value. So when the base is 3, 3 to the 4th will give me 3 to the 4th. When the base is 4, 4 to the 3rd give me 4 to the 3rd. 4 raised to the 3rd power give me 4 to the 3rd, and so on. And Lin does pretty much the same thing with a different base on it. Lin is nothing more than log base E when the base is a E. And so this is asking that question. Ln of e to the -7 is going to be -7. E to the ln, they're inverses of each other. It's going to be 6. And this one here we have e to the ln. Gives me a square root e to the ln. Undo each other, you know what square root of 4. And ln of, you can rewrite that as ln of e to the -2, which is -2. They undo each other. And this one here, and this one, there's nothing written there. It's assumed that it's a 10. So this, and then the calculator is already set up and built into the calculator for log base 10. So you just put that into your calculator. Clear. as a log. And I have what? 590. Hit log. And there's the value there. And this one here is log base 3. Okay. Log base 3, evaluate using your calculator. For this one here, you have to use the change the base formula. And you see the change the base formula here. And we have to divide. So it's already built, log base 10 is already built into it, to the calculator. So we have to take the log of 0.91, log of 0.91, there, 0.91, the log of that, and divide it by 3. Take the log of that and hit equals. And I get my answer there. 0.0858 negative. And wait. 0.8. And that's your answer. If you change the base formula to do that one. Next one here, let's go down one more. Write the equation in exponential form. Assume all constants are positive, not equal to 1. So in exponential form, you're going to have 6 squared. You can exponentiate both sides. So if this is true here, so if that's true there, and I can do this, 6x 2, I can make 6 the base using the exponential form. Okay. And these will undo each other. And I end up with 36 is equal to 6 squared. And that's my answer. $15. So in this case here, find the natural log without using the calculator. So here I have the log base 2 of square root of 2, the fourth root of 2. So here I have it written out. I can rewrite this inside here as being 2 raised to the 1/4 power. And now I want to take the natural log of it. What is the exponent for the base 2 that'll give me 2 to the 1/4 power, which is 1/4. So this uses the idea that x, square root of x, is the same thing as x to the 1/2. So the fourth root of x is the same thing as x to the 1/4. That's what I did here. 16. $7,000 is invested in an account at an interest rate of 8% per year, compounded continuously. Meanwhile, $46,000 is invested in the bank accounts at an interest rate of 5% compounded annually. Okay. To the nearest year, we want the two accounts have the same balance. Okay. So one is growing at a rate of 5%, so that's exponential, and one is growing continuously, and that's the 7,001 here. So they want to know when have the same amount of money in it, so when the two formulas will be equal to each other. And they want to know when, so t, we have to solve for t. So I set both the formulas equal to each other here. You can see right there, compounding continuously, that's the formula for it. All right. So I set both of these equal to each other and I end up solving for t. So I divide both sides by $46,000 and I have that value there. And I want to get t on the same side, so I divide it by e to the 0.0t, 0.8t. That's how I got that there. So I have this part done here. Okay. When I get to this point here, notice that t has a base, on the numerator I have a base raised to the t power, and I have e here. What I need to do is rewrite this numerator in terms of e raised to some exponent. That's what I have to do next. So I have e here and e here. So over here, right here, I take care of that. I have to solve for k to find that exponent. So I have e to the k is equal to 1.05. So the opposite of, I have to undo the k, e to the k, so take the natural log of both sides. It tells me what k is equal to. Okay, so that e to the k is equal to 1.05. So now that I know what k is equal to, I can rewrite this here. Alright, so I have a quotient here with the same base. I'm dividing, so I can just subtract that. You subtract your exponents, and I get that value. All of that is equal to 0.15, 217391. So once that's done, I have to solve for t. Again, see t right here. So I take the natural log of both sides. Okay. So I take the natural log of both sides. And it undoes the e. And I take the natural log of this and I get that value. Then I can solve for t by dividing. And when I divide here, and it tells me that t is equal to approximately 60.34 years. And that's how you go about doing that particular problem. And that's number 16.